Hey guys, I'm Vijaya. So today in this session we are going to learn about cascading referential integrity constant in SQL. So cascading referential integrity constant in SQL are rules that automatically define the actions taken on the related, that means the child table, when a user attempts to delete or update the primary key in the reference, that means the parent table, and that is implemented using the on delete and on update clauses in a foreign key constraint. So there are four types of cascading actions. The first one is the cascade. If a row in the parent table is deleted or its primary key is updated, then the all corresponding rows in the child table are also automatically deleted or updated. The next one is the no action. So this is the default behavior. If an attempt is made to delete or update a parent key that has an existing foreign key, then an error is raised and the action is rollbacked. The third one is the set null. When a row in parent table is deleted or updated, the values in the foreign key columns of the related rows in the child table are automatically set to null. So this requires that the foreign key columns in the child table must be nullable. And the last one is the set default. The foreign key values in the child table are set to their predefined default values if the parent row is modified or deleted. So this requires that all foreign key columns have a default value defined for. We are going to talk about a very important SQL concept that every beginner needs to master, and that is cascading referential integrity constant. I know the name sounds super technical and intimidating, but I promise you, by the end of this video, you will understand it perfectly. Let's break it down into plain English. Use a real life example and look at all four practical ways you can use it in SQL. So what is cascading referential integrity constant? Imagine you have a YouTube channel that is parent table and your videos is child table. So every video you upload belongs to a specified channel. This relationship is created using a foreign key. That means the channel ID in the videos table. Now referential integrity is a rule that says a video cannot exist without a channel. But what happens if you delete the channel entirely? What happens to the videos attached to it? This is where cascading comes in. Cascade simply means the chain reaction. Cascading referential integrity tells SQL exactly how to handle the child records videos when the parent record channel is deleted or updated. There are four actions you can choose from. Let's look at all of them with simple SQL example. So here we will first create a database YouTube. So let's create it. Now our database is created. You can use this code also to select the database in the context menu. Now here we are in the YouTube database. Now let's first create the parent table. So here in this YouTube database, we are using the tables, that means parent table and the child table, to see all these examples of cascading. So let's create first the parent table. So here we create table channels, that is the parent table, and here in the channels we are having two columns, channel ID and channel name. So let's create it first. Now we created the table channels. Now let's insert some data into this channel. So two rows are affected. That means two data are inserted in this channel tables. Now let's see how the four different cascade actions change the way we are create our child table, that means videos. So we have created the parent table. Now we are creating the child table to see all these 4 examples of cascade. So the first one is the cascade. Cascade means if the channel is deleted, delete all its videos automatically. If you delete a parent record, then SQL will automatically go into the child table and delete all related records. So no manual work, you have to do it. So let's first create this child table video cascade. This is the first example of cascade. So here in this videos cascade, we are having 3 columns: video ID, title, and channel ID. So let's create it and execute it. Now our child table is created. Now here we are not using the identity column value. Okay. And in this way, you can also use the foreign key constraint. That means we have defined the column name first, then putting the comma, and in the next line, we are using this foreign key constraint. So foreign key channel ID. This is the channel ID of this videos cascade, and it references to the channels table. That means the parent table. And this is the channel ID of the parent table. So what is the condition? On delete cascade. Okay. So on delete cascade means if you delete a parent record, then SQL will automatically go into the child table and delete all the related records. So let's first see the data we have inserted in this tables, in this code tables. Now here, we didn't insert the data in the child table. So first insert it. Okay, one row is affected. Now select the data from both this table. Now here you can see that this is the parent table. In the parent table, we are having 2 columns, channel ID 1 and channel ID 2. And in the child table, we are having only one column. That means video ID is 101 and the channel ID is 1. That means this channel ID and this channel ID making the relationship of parent, primary key and foreign key constant. Okay. So now let's test the data. Delete the channel. So delete from channels. That means from this table where channel ID is 1. This is the channel ID. And here in the child table, we are having only one column, and that is the channel ID 1. So let's see what will happen. So delete from channels where channel ID equals to 1. 1 row affected. Now select the data again. Now, result you are seeing here, the channel is gone in the child table and video 101 is automatically deleted. So that is the use of cascade. If you delete the child record, then if you delete the parent record, then child record will automatically delete it. No manual work you have to do. Okay. This is one cascade. Now the second one is the no action, strict bouncer. So stop, you cannot delete this channel because it still has videos attached to it. So this is the default behavior in SQL. If you try to delete or update a parent record that has children, SQL will throw an error and roll back the transition. You must delete the child record first. Okay. So this one is the second. So now again create the child table, create table videos, no action. So in this child table, we are having 3 columns: video ID, title, channel ID, and this is the constant foreign key. Channel ID references channels table, column is channel ID on delete no action. So first create this table. Okay, commands completed successfully. Now insert the data into this child table. One row is affected. Now select data from both this channel, both this table. Now here in the parent table, that is the child table, we are having only one record because in the first example we have seen in Cascade, the channel ID one is deleted. Okay. Now this one is the second example of no action. So here we are having channel ID 2, and here in the child table we are also having the channel ID 2. So test the data. So now try to delete the channel. Delete from channels where channel ID is 2. So now let's see what will happen. Okay, error. So the delete statement conflicted with the reference constant FK video no channel. So the conflict occur in database, IT, table DBO, videos, no action, and column is channel ID. The statement has been terminated. So here from this error message, you can guess that Asper says that no action can be taken because video 102 is depends on it. So here in this way you cannot delete the child record which is parent table is belongs to. So this one is the second example. So you cannot delete this channel because it still has videos attached to it. So, and this is a default behavior in SQL. If you try to delete or update a parent record that has a child record exists, so SQL will throw an error and roll back the transaction. In this way, you must delete the child record first. Means if you want to delete this data, then you have to first delete the data from the child record, child table, and then from the parent table. Okay. Now, this one is the third example, set null, the output maker. That means if the channel is deleted, okay? If the channel is deleted, keep the videos but erase the channel name from their records. Okay? So when the parent is deleted, the child records are kept, but their foreign key column is set to null. That means the foreign key column must allow null values for this to work. So let's create this child table. Here in the child table, this is the child table name video set null. Here we are having three columns only: video ID, title, channel ID. This is the foreign key constraint. So notice here, this is the channel ID int. Okay, notice we don't say not null here. Okay, so let's create this table first. Our table is created. Now insert some value in this child table. Okay. So the insert statement conflicted with the foreign key constraint. Okay, the conflict occur database YouTube table db.channels. Why this error is coming? Have you guessed? Now why we are getting this error? Because we have previous we have seen in the previous example of Cascade and no action, we have deleted this channel ID 1 in the channels table. So that's why we are getting this error because the channel ID 1 is not belongs to this channels table. So first insert this data into the channels table. Okay. Now let's insert this data again. Okay. Now select the data from both this table. we are getting this error because in the previous example we have deleted this channel ID 1. So we don't have this channel ID 1 in the parent table. So that's why we are not able to insert the data in the child table. So that is the use of the primary key and foreign key constant. If you don't have the record, then the data is not inserted in the parent table or child table. Now we have inserted the data in both this parent and child table. So now let's test this data. So let's delete the channel, delete from channels where the channel ID is 1. Okay. So let's see what will happen. 1 row is affected. Now again select both this data from the tables. Oh, now here you can see that we have deleted the channel ID 1 from the channel table. But now here in the child table, you can see that the channel ID 1 is gone. But here, instead of the data is gone, you can see that null value is displayed in the channel ID of the child table. That means in this example, if the channel is deleted, okay, that means the channel is deleted in the child table. Keep the videos. This video ID is 103 and the title is gaming stream. So keep these videos but erase the channel name, that is the channel ID 1. Okay. From the records, when the parent is deleted, that means we have deleted the record from the parent. The child records are kept as it is, but their foreign key column is set to null. So this is the foreign key column and here it will set to null. That means the foreign key column must allow null values for this to work. So this is the third example of set null. Now let's see the last example. So here you can see the channel is gone, but videos 103 still exists, but its channel ID is now set to null. So that is use of the null cascade. Now the last example is set default. That means if the channel is deleted, reassign the videos to a default unknown channel when the parent is deleted. The child records are kept, but their foreign key is changed to a predefined default value. That means the child column must have a default value defined and that default value must exist in the parent table. So now let's first add a default value in our parent table. Insert into channels values, ID is 99 and the default value is unknown channel. Let's insert this data into the parent table. One was affected. Now let's create this child table. Video set null. Video ID. Here we have 3 columns: video ID, title, channel ID. And here for the channel ID, we are creating the default constant and the default value is 99. And this is the constant. Foreign key, channel ID references channels. That means the parent table, the channel ID on the condition is on delete set default value. The default value we have defined in the parent table is unknown channel. Now let's create this child table first. Okay, our table is created. Now again we have to insert the values for channel ID 1. First insert the data in the child table because we will now getting the same error that we previously were getting in the third example of. Let's execute it. Okay, same error we are getting because the channel ID 1 is deleted. Now let's insert this data. Okay. Now insert this data into the child table. Now select the data from both this table. Okay. Now here you can see in the parent table the channel ID is 999 and the default value we have created is unknown channel. And in the child table, this is the channel ID 1. and the video ID is 101. Title is log shift per. Now let's test the data. Delete the channel. Delete from channels. Okay, delete from this parent table channels where channel ID is 1. Let's see it. Okay, 1 was affected. Now select the data from both this table. You see the result. Okay. Now here you can see that the channel is gone. Okay, means the channel ID 1 is gone from the channel table. Okay, that is a parent table. But video 104 is still exists and its channel ID is automatically changed to default value is 99. That means the unknown channel. Okay, so in this way you have seen all this for example of cascading referential integrity constant. So, and that's it. Cascading referential integrity is just you telling how SQL handle the leftovers when a parent record is removed. So if this made sense to you, hit that like button, subscribe to the channel, and let me know in the comments which cascade action you use the most in your project. So keep coding. I will see you in the next video. Till then, stay safe and bye.